Good evening, all. We are delighted to welcome Mr. Madhusudan to today's session. Madhusudan earned his undergraduate degree from National Institute of Technology, Tiruchirappalli, and a Master of Engineering in Software Engineering from Birla Institute of Technology and Science, BITS Pilani. With 19 years of extensive experience in software engineering, he has contributed to various technology domains, including Java, Android, and web development. A passionate mentor, Madhusudan has guided numerous junior associates and championed automation testing practices for mobile and web applications. Currently, he serves as a cloud and DevOps engineer at Trimble, where he continues to innovate and drive excellence in software engineering. Earlier in his career, he worked with Cognizant and Caterpillar. Please join me in giving a warm welcome to Madhusudan. Welcome you, sir.
Thank you, Murugan. Thank you, sir. Can you hear me and can we get started?
Yes, sir. You are audible, sir.
I share the screen and we get started
Okay,
from
okay.
there.
Yes.
Are you able to see my screen?
Yes, sir. Can you make it full screen?
All right, sure. I go full screen now. Okay. Good evening, all.
Yeah,
Welcome
yeah.
to today's
Now
session.
it's full, sir. Thank you. Thank
All right, we get started with today's session. So I have some more introduction about me and AWS. So as Murugan said, I am currently with Trimble. I work as a cloud engineer and DevOps engineer. That's my current role at Trimble now. So for the last couple of years, I am into AWS. So I continue to learn AWS, and they never fail to fascinate me with new services and offerings. Right. So far in my learning in the last couple of years, I gave 3 certifications in AWS, but still to me it feels like a drop. A wise man once said, known is a drop and unknown is an ocean. To me, AWS itself is an ocean. There are lots of services that solve a lot of problems. And the way they have developed their entire ecosystem, it, it helps different industries, customers from different industries, and solve problems at a very, very large scale. I personally like AWS because it has great documentation and getting started examples. I am a self-learner, so for people like me, and I think for you also, research students or professors, I think AWS may be a great place to start, and especially for IoT or machine learning, artificial intelligence. They offer a wide range of services across different regions and at a very optimal price. So talking about AWS and cloud, there is one more thing that I wanted to cover. There is a common belief among people or people who work in industries or in the teaching profession that one should go to cloud only for compute and storage, right? And mainly because it's relatively cheap or it's less costlier, right? But to me, cloud is not that cheap, but you are priced nominally, right? And one should go to cloud mainly because of the managed services they offer, and enterprises still see a great value in going to cloud, not because of the cost, but they get great benefit from security and compliance perspective. And this is very important for industries that rely on IoT and machine learning because they are going to deal with large amount of data. And with large amount of data, there is every possibility that the data leaks could happen or sensitive data might be exposed. So compliance plays a bigger role for enterprises, right? And that's where they go and rely and stick with the industry leaders like AWS or Azure or Google Cloud. Right? If they are just looking for compute and the storage, they can go to other providers like DigitalOcean or Linode, right? Alibaba Cloud, right? But the main difference between the top three players and the remaining service providers is the managed services and the security and compliance. And moreover, like I said, the documentation, the amount of effort they put in to create the documentation, examples covering different languages, they all come and help to help people to quickly adapt to the cloud environment and services. Okay? So with that, I will just give a heads up about this session as well. So I know these sessions are going for the last 1 week, right? And by now you might have heard the fundamentals of water management. You might be thorough with the fundamentals of machine learning, AI, right? So I'm going to, this session will focus a little more on AWS, how we solve the water related problems using AWS. And if you are totally new to AWS, you might feel this session a little technical, but trust me, there is not much of technical content in this session. I just cover at a high level how AWS plays an important role in machine learning and artificial intelligence, and how we can solve some of the water management related problems with AWS. Okay. That said, we'll move on. I So I just talk about the company I work for now. The mission of Trimble is to transform the world the way the world works. Right? And what they mean by transformation is bringing together the hardware, software, and services, and make the way of way of the way the customers workflows or activities are um, they try to make the customers workflow much easier and more effective and perform in a better way, right? And Trimble as such is a product company, and they are well known for their positioning technologies. And yeah, we Trimble has their own set of hardware sensors that help them serve a wide array of industries like agriculture, construction, transportation, geospatial industries. Right? I have placed three images at the bottom. On the left is a software called Trimble Ag, which is mainly used in the agricultural industry. It is mainly meant for farmers to take care of their farming operations and their workflows. Right? And the second one is the product that I currently work for now. It's Trimble Earthworks. It's mainly meant for heavy machines like excavators, dozers, paving machines, compactors, milling machines. Right? And on the right, top last right towards the end, what we have is Trimble Unity. So that is one of the software that is meant for water management. So all these have just one thing in common. So we have different sensors, and these sensors collect data and give it to us. And Trimble already is a leader in positioning. And positioning, when I say it's up to a millimeter accuracy of positioning. We can easily identify the location of a machine to 1 millimeter accuracy on the field. Right? So once we have that much of accuracy in positioning the center of the machine, then the rest of the part becomes engineering. We can easily measure where the other parts are. For example, if it is an excavator, we can easily measure where is the bucket. Right? And when we know where is the bucket, we can easily apply the core logic inside of the processing unit, and then we can make the machine move. Right? So that's how we are able to give guidance and automatics to all these heavy machines, right? And in all these products, we Trimble, just being on the technology side, we partner with the domain leaders. For example, the agriculture software is now currently owned by AGCO. That's a company name. And the earthworks and roadworks, Trimble has joint venture with Caterpillar. And on the right is Unity, which is kind of a joint venture with Badger Meter, is a company name. So they are leaders in water management solutions in the Europe. Okay, so that's about Trimble. So we'll get into business. Why is water management important? Right? There are a lot of factors that we can say, a lot of reasons we can say why water management is important. Right? But I have captured the top 5 reasons so that we can easily recollect the why, and then we proceed to see how we can solve the problem. Right? One is the population is increasing, and we have to meet the water demands of people, and people use water in multiple ways for domestic purpose, drinking purpose, industrial purpose, right? And then agriculture is another industry where which demands large amount of water. 70% of water they need are the freshwater resources. Right? And then there is a climate change that is happening as well, which is not in our control. Sometimes there is drought on the same region, and sometimes there is flood. And then the main water sources are getting polluted, either directly or indirectly. Sometimes it's accidental. Sometimes oil spillages happen on the oceans, right? And then because of rainwater or animal waste, biological waste, they get slowly accumulated in the water resources, and they start polluting the water resources above the surface or below the surface, even the groundwater. And the drinking water, they have to be uh, germs free, right? So otherwise, we will get a lot of health hazards if the drinking water itself is um, not pure, right? So water management is important for all these purposes: domestic purpose, industrial purpose, right? So how, if the water management is important, how are we managing so far? Right? On the left, there are few techniques that anyone can commonly use. We can see that in practice: rainwater harvesting, drip irrigation, sewage treatment plants, community ponds, public awareness campaigns. All these things happen regularly, right? And I think 2 3 years before, the government was insisting more on rainwater harvesting. I think even now, when you try to register a house, I think as part of the plan, the rainwater harvesting has to be there. Sewage treatment plants, you can very well see in all apartment communities. They try to reuse the water at least once. The domestic water, they get recycled for parks or for gardening purposes. Right? And community ponds also, which getting it's getting more importance. Big apartment builders or even on villages, metro cities, people as a group, they come together, they volunteer to have community ponds, right? And there are advanced solutions as well, which industries mainly prefer. For example, precision agriculture, drone monitoring, IoT sensors, and AI, smart water meters, water management software. So there are certain advanced solutions, but these advanced solutions are not applicable for everyone, right? Because the special problem or the special nature of water is that there are a lot of factors related to it. So the problem is not same everywhere. The solution is also not same everywhere. So with that, we'll see what makes water management challenging? Right? Let's take small houses, right? Even at a home, right? Understanding the demand and impact itself is challenging. Unless you are in an individual house, maybe if you live as a family of five or four, maybe one person will know how much of water is needed per day. Right? Maybe the father, if he is turning on the motor and he's tracking that, he knows, okay, today morning I fill the tank, it will come and meet our needs for next 24 hours. And people who live in apartment community, there is very little chance that they are even aware of how much of water they use, because the association takes care of filling the water tanks, right? And they will never feel, or they are never exposed to the amount of water they consume. Right? And then there is human negligence as well. At home, if your kids are wasting water, at most of the time we may not interrupt them and stop them. Okay? And sometimes rainwaters, they go outside our house, and not only rainwaters, they get mixed with the sewage waters that go outside the outdoors. Okay? So human negligence is a big challenging part at home. Whenever human is involved, I think the human psychology is very tough to predict, right? So that's a problem, or that's a challenging at individual home level. And then for small scale industries and farmers, the biggest challenging part when it comes to water management is the cost. It, either they have to put some capital, they have to spend a big amount and acquire some smart solutions or electronic appliances to control the cost, and then the maintenance will become an overhead as well. Right? And there are infrastructure limitations. For example, most of the small industries, they start at the outside or at the outskirts of the city. Right? And there we will never know whether they will have electricity at least. Right? Forget about internet there. Even electricity could be a challenging one. And most of the small scale farmers, they are relying on free electricity from the government, right? And if we go and propose them, I have a solution for your water management problem, I have Internet of Things, then it will be of no use for them, right? And then compatibility with existing practice. Even when we give them a free software, right? The way they practice or the activities that happen within the industry, it may not work well with the existing software. And for small scale industries and farmers, it's very, very hard to justify the investments. They always look at short term. Right? And they will say, okay, I'm doing this for 6 months. Next next 6 months, I'm going to cultivate or to take crops that are not water thirsty. Right? And then lack of technical expertise is again a big challenge for all the small industries and farmers to adapt to any of these advanced solutions, or even continue practicing the basic techniques. When that is the case with small scale industries, what are the challenges that large scale industries face? They have the resources to buy the software or technician support. But on top of that, they will still have integration issues because of their size. There will be the multiple divisions, or they will have their industries in multiple areas. Right? And water problems are very specific and they are controlled by the region specific factors as well. Right? Arid regions, semi-arid regions, all will come into play. So again, they have to do customization on top of what they buy. And dependency on third-party vendors, sometimes when they need, the vendors may not be available. And most of the solutions that are available, they are not scalable. because of their huge nature in size. So these are the challenges currently that are faced by different industries. So we looked at the challenges. So whenever there are challenges, it also brings us, um, it also tells us that there are opportunities to improvise, right? So we as individuals or as a team or small startup or small company, when we are trying to solve the water management related problems, so these are the things that we have to pay more attention. If the problem statement comes to you from a small or mid-sized industry, then you have to look for solutions that are very much cost effective, modular, and it has to be, it can be a cloud-based solution, right? So these are some of the opportunities where you can provide. When I say modular, I mean that you can give a solution. Maybe your solution may not fix all the 10 problems the customer has. Maybe it can fix just one. And then maybe you can give the second fix on top of that. It should not be like either you get the entire thing or you get nothing. Right? For example, um, there are you can take a look at how the speakers currently, like speakers from big brands, for example, Sony or Bose, they give the sound bar, but if you need, you can upgrade and buy a woofer, and you can buy the rear speakers separately. Right? This is modular, and when you combine them, they all work together. So same way, the Raspberry Pi or Arduino is another example. You just get the board, and if you need additional features like Wi-Fi or Bluetooth, you connect additional modules. Right? You buy additional modules and load to it. That is what I mean by modular. And most of the small sized or mid-sized industries, they don't need machine learning or artificial intelligence. All they need is just a simple monitoring, right? Because they currently do not know how much is the wastage, and they are not even collecting the data. Only when they collect the data, they know whether they are running efficiently or there are a lot of loss, water loss or resource loss is happening. Right? And the cloud-based solutions I mentioned here because there is no capex involved. Even for they can try small, and if they don't like it, they can stop it. The risk that we take with cloud is very minimal. And for large industries, we should try to see how we can improve their existing process. For example, we cannot propose a totally different solution for them, but we can see how we can take remediation actions in real time. For example, if there is a failure that we could detect, instead of just only alerting, how can we even prevent that? Okay. And large industries, since they generate a large amount of data, we can generate more insights and to find where and all we have opportunities to optimize their solution. And how can we automate at scale with less downtime? Because they will have dependency on their external customers. So we cannot take their system down and do the scaling. We have to see how much we can automate all the scaling processes, or when we introduce new solution, it has to be in a slow and automated way. Right? And security and cost is where most of their spends will go. So if we can provide a solution that is more secure and less costlier, then definitely the large industries will look forward for that solution. So currently, with that said, the challenges and opportunities. So how are the large industries currently coping up with these problems? Right? So listed on the left are all the domain experts: Veolia, Ecolab, GE Digital, Cisco, Siemens, Honeywell. they all have tied up with some of the technology giants to solve their own water problems. It's, it's not that Siemens is a hardware company, but they, as uh, for their entire infrastructure, they will need lot of water, right? And they dispose lot of water, and how can they treat them? So that's how large industries were able to solve their problems, solve or mitigate their problems. They, since they have the resources they need, they can easily have tie up with technology companies where both can work together. The domain experts will share their problem, and the technology experts can provide the solution. And when these two are combined together, they get a robust solution. So yeah, in this I have mentioned just one thing. Most of these are water-related solutions. GE Digital and AWS on the third point. It's IoT-based industrial water management. Right? And Siemens and AWS integrated IoT sensors. Honeywell and AWS industrial IoT solutions. So far, we heard about IoT solutions, but this one is relatively new. Like the term industrial IoT, it stresses more on the scale. Right? We will see what industrial IoT means in the next slide. Okay. So the difference between industrial IoT and normal IoT is most of the time whenever we say IoT, it's more consumer focused. For example, it could be smart locks, smart speakers, connected vehicles, and these focus on enhancing the customer experience. They do not solve problems as such, but they try to enhance the customer experience. Right? They collect the IoT devices that we currently have at homes. I mean, the wearable devices you wear, they all collect data for personal use, and they provide some convenience options on top of that. Right? They rely on low power Wi-Fi or Bluetooth cellular networks, and the IoT in general, they operate at small scale. When it comes to industrial IoT, it is meant for industrial grade applications, and even the sensors they use, the actuators they use, robots they use, they will have high precision and accuracy, and they require more secure industrial protocols, for example, MQTTs and the Ethernet, right? And they target, they operate at much larger scale, and they target factories and big energy grids in any industry. So that's the difference between IoT and industrial IoT. And jumping back to one of the previous slides. So that said, we talked about the challenges, we talked about the opportunities. Now we can think of how we can solve. Right? If someone approaches you, right, with a problem related to IoT, right? Or if some of your students come and approach you saying, sir, I'm trying to solve this problem. Right? We should be in a position to guide them. So the best way is to understand the problem better first. And once we understand the problem, we can think about solutions. Right? And even when we think about solutions, the important thing is that we should not go just in one path. Right? We should evaluate multiple paths and then arrive at the optimal solution. It's not that we pick just one solution and we stick to that. Right? IoT, machine learning, multimodal AI, all these may not be the answers for the problem in hand. Right? So best thing is try to understand the problem and then see how we can address that. Right? So in this context, we can have a combination of that. Sometimes the water management problems could be solved just with IoT and analytics. Right? IoT is meant for collecting the data. Right? And once you collect, you can do a query or do some analysis on top of the collected data, and you get a picture, right, where we stand. Then the decision could be how to stop the loss or how to make corrective action. And sometimes it is enough if we do just manual review of the collected data by plotting them in charts, right, or graphs. That would be helpful. But when the amount of data grows more and the problem is also very uh, not that much, it's not that much easy to solve, then we have to involve machine learning. Whenever the data set is huge, and if needed, we can also think about multimodal AS. If instead of just relying on text-based machine learning algorithms, we can combine different models like voice-based, images-based. So all these can be combined, and even maybe a combination could help. A combination of um, models could even enhance the user experience and give better, but can become a better solution. So we will take a look at how IoT works. We talked about the different options, right? IoT, analytics, machine learning, and AI. Right? So we'll take step-by-step approach. We'll first see how we can collect the data, and that is where IoT helps. Right? And IoT has just four components, four different tasks or stages. Right? One is you collect the data, and then you transmit it, you process the data, and then you visualize it. Right? And how do we collect the data? It's through sensors. How do we transmit? We use the network technologies like Wi-Fi, Bluetooth, right? And how do we process the data? Sometimes we need to apply some transformations on top of the data we get. Right? That's where we need devices like Raspberry Pi could help, and then the output of that could be visualized in application. That application could be a web application or mobile application. On the bottom, it's a slightly more advanced or a complex solution of how IoT works. We have devices or things, and then there is connectivity. The network will be there. And then the edge computing will happen on the exact place where we are collecting the data. Right? And then the gateways will be there, and gateways will be used when we have more sensors. When we have thousands of sensors, and these sensors, they share data in different formats. Right? So all these come to the gateway, and from the gateway they will go to the server infrastructure. And the server infrastructure, again, it need not be cloud. It could just sit in your on-prem, or it can be on the cloud as well. And it could be, in this case, it could be just an EC2 instance or a web server running on the cloud where you have hosted your web application. So here the additional thing that we have is the introduction of edge computing and gateways. These two hardwares, based on the complexity, based on the amount of sensors involved, based on the nature of data, we can go for adding more um, computing power to the area where we collect the data. We move on. So a lot of sensors are available. So for the given problem in hand, we have to carefully identify and choose the sensors. Right? And within the sensors also, there will be different grades, different brands. Right? That, for example, the temperature sensor, we might find three different variants of temperature sensors. Right? We have to choose based on the need, what level of accuracy is important for us, right? And the critical nature of the job that or the problem that we are trying to solve. Right? And the frequency of data is also important. Some sensors will transmit or emit data irrespective of um, irrespective of the change in the value. For example, one sensor can continuously emit the current temperature every second. Or some sensors could intelligently emit the data only when there is a change in temperature. Or some sensors can send the same data, but they will have limits. For example, they can send the data only after 30 seconds. Only every 30 seconds or every 5 seconds can only they can send. And they might need a lot of battery or the continuous power supply also. So considering these constraints, we have to carefully pick the sensors. And once we pick the sensors, the next step is to identify what is the next component that I have to use for gathering or collecting the data. Right? There also, we have three different options. These are just top three, but you might find a lot of other devices as well. These three are commonly used in IoT related projects. So one is Arduino, Raspberry Pi, and Node MCU. Okay. So these are also they have different behaviors, so they can be become beneficial for different use cases when you really need high power, high processing power. Okay, we cannot go for Arduino. We have to go for Raspberry Pi, that where we can install the OS, install the software we want, and do the computing. And in some places, if we really just need Wi-Fi and don't have much of the computing needs, all I need is to transfer data, then Node MC could be a better option. Right? So yeah, you have to carefully choose the options, evaluate the options, and choose the best one for the solution we want to provide. Okay. So we talked about the sensors, we talked about the edge computing, or the additional resources we can deploy on the place we collect data. So once we collect the data, what are we going to do about that? That's where the IoT platforms come into picture. They help you capture the data and then perform additional operations on top of them. Right? There are options available within the open source platforms, and there are options available in cloud platforms as well. You can evaluate each of them and then see what best works for you. Right? Things board is one option, like IoT, car IoT. These are all open source. Right? And there are cloud-based options as well. And the images on the right, they are very specific to AWS. So I will just go over the AWS related services in this, but feel free maybe after this session, whenever you have time, please explore the other options as well. That will give you more insights and how different platforms are trying to solve the consumer or customer's problems. So IoT platforms, they mainly have four categories: producers, then the collection happens, storage, and presentation. And sometimes after the collection happens, we do strong data processing, right? And that is called ingestion, then stream processing, and then storage. The processed data will be stored either in a file system or a database, right? And then Amazon QuickSight is one such service where you can easily do query-based, SQL-based queries, and then plot graphs and charts. Right? By they have a lot of built-in charts that are readily available, so we need not create our own web application, deploy them to see the charts or to see the patterns. But we might need some experience or some knowledge in SQL queries so that we know how to query and get the data. And once you have the data, the quick site can easily plot the required graphs. Right, we move on. So On top of the on the heart of AWS IoT services is the IoT core. Okay. The IoT core is the one that connects all the devices from the on-prem or from the remote location to the AWS platform. So it provides authentication. It makes sure the communication is encrypted. On top of that, the IoT core, they have their SDK that the devices can embed within them and use them to talk to IoT endpoints. And the IoT core also, it creates an MQTT broker on the AWS side, and it exposes that. So the devices can talk to the IoT core through the MQTT channel, right, which is secured based on TLS 2.1, and it applies a certificate-based mechanism for authentication for devices. And the IoT core also has a rule engine, which is also very much SQL-like based, and which that helps you to filter the data and then redirect. It helps to redirect the rule engine, helps to redirect the data to different other services. For example, once the data comes and reaches AWS, where it has to go. Maybe it can be the data can be just saved in S3, which is a storage service, or it can be stored in any of the databases. It could be DynamoDB, which is a NoSQL based database, or it could be sent to a Lambda function, which is a serverless option to execute a particular logic, or it can be sent to Kinesis data stream, which is also a managed service. And then once the data is processed, they can be stored in a different S3 bucket or different storage space, from where the other analytics softwares like QuickSight or Athena can read the data and generate some insights. Or they can further apply for transformations, or they can enhance the data further and use it for further processing and storing. Right? So the IoT core is a very important part to get started. Maybe I will quickly show you how easy it is. Okay, I am in my AWS console. Right, I just log into my AWS console, and I just went to here and selected IoT core, AWS IoT. Right? So get started with AWS IoT. So earlier in the past, getting your device connected to AWS cloud would be very cumbersome and tedious process. You have to manually download the certificate. You have to make sure they are properly connected via the SDK. But now they have made it very simple. So within few minutes, you can easily connect your new device. For example, I do not have a separate IoT device for now, but this for this demo purpose, my PC or my laptop can be considered as an IoT device. Right? So I just clicked on connect on device, right? And it gave me an endpoint where the devices will be connecting here. I just click on next, create a new thing. You can just give the device name. For example, if it is a thermometer or temperature based sensor, you can just whatever unique name you want to give for the IoT device. In this case, I will just choose an existing thing. Just before the demo, just before the session, I created this one. So I have created this, already created this MSGPC, right? And then I click on next. It will ask me what is your platform. My PC is running on Linux, so I just select Linux. And then the IoT device SDK is available in 3 languages. Most of the research students, professors, like they are well versed in Python. Python is more comfortable. So you can select Python, right? But I have tried with Java. So in this example also, I'm going to just select Java. You can, for your trial, when you trial, When you try, you can select Python or Node.js based on whichever language you are comfortable, and then click on next. Then it will automatically generate the connection kit, right, which involves all the certificates. It includes a separate script that you can run to kickstart or get your workspace started, right? And then click on download connection kit. Right? So this will download a zip file which is very small in size, right? And then you have to do the unzip. And then when you click on next, right, it automatically creates the MQTT broker, and it enables the subscription. It says it's waiting for message. I'll switch to my ID here, and then I'll execute the start.sh script that the documentation mentioned. Right? And this needs Maven to be pre-installed, Java to be pre-installed. Other than that, nothing else. It will automatically pull the SDK, the sample SDK example from the GitHub, right? And it will do the compilation. It will start the correct service or the correct class, and that will just start posting the messages, and you are seeing it here. So this is that easy. So you can now take this code example, right? This GitHub repository has samples for different use cases. For now, all I am doing is the basic pub and sub. Right? So you can take a look at this. It's not that you have to start from the scratch. You can quickly get started with your IoT related researches. Right? You need not worry about the other connection or certificate related issues. You can start focusing on the core part. Wherever you are sending the data, you can see if you want to add some debug statements, or if you want to add additional logs before you push your data, you can do that. Right? This is that easy. So this is not only for this particular service. You can take any service in AWS. You can easily find a quick start example, and even for deploying servers, even for managed, if you want to just start any managed services, there will be an example and well documentation available as well. It will detail, well written documentation available as well for that. I will switch back. We talked about IoT core, which acts as an entry point for your data to reach AWS. And once it reaches AWS, we can apply, or we can do some analytics operations on that. So a quick, very simple example could be your IoT sensor sends data, it reaches the AWS cloud, and IoT core, we have this IoT rule option. So this is also available in the UI itself. Most of the operations or activities that we do, it's not necessary that we have to do via the AWS CLI or only the AWS SDK. The, uh, the the rule configurations can be done via the UI itself, like how I clicked on connect a device and then download kit next. So AWS behind the scene automates a lot of them. So rule, we have an option. What do you want to filter? Right? And in the rule, you can just give a name and write a simple SQL based query. For example, if the data that you receive is JSON based, right, and it has multiple attributes, you can query if the attribute, for example, if the PH attribute is greater than 7, right, write to this particular database. Time stream is another service that is available on AWS. For you can just add an entry or add a row or record in the table. It will automatically append the timestamp along with that. And this time stream database will be useful for generating any time series based graphs or charts. So QuickSight is one option that we already saw. Right? It has a lot of inbuilt charts and graph options. We can easily plot different based on different input parameters. And the same is the case with Grafana. Grafana is actually open source. You can even now install it on your Windows PC or Linux PC on your home personal laptops and try it out. It, by default, it is also baked with lot of different options. How it's not only charts, but how you want to visualize your data. That's what Grafana focuses on. And it does not store Grafana does not store any data, but it relies on it has built-in data source connections. So it can connect to any database. It can connect to MySQL, Postgres, and within AWS platform, it can connect to time series, time stream database. It can connect to DynamoDB. It can connect to S3. Right? All it needs is a data source. It can do Oracle database. Once you have the data source connected here, again, Grafana is a little more powerful as well. You can not only you can store the data here in the way you want, the data or chart can be dynamic as well. Based on the threshold value, you can make it either look red, green, or yellow. And on top of that, it has an alert manager built in as well. So if the threshold goes below the desired value, Grafana itself can send an alert. Okay. So Grafana can be a very, very simple solution when you want to measure or you want to collect your data and just measure what is happening. Right? When you want to just observe what is your current state of the system, what is the current state of the system. Okay. So this is a little more advanced way of doing analysis with the data we collect. Okay. So here it involves some more processing, and we mainly go for Kinesis data streams when the rate at which the data emission happens is more. Okay. Sometimes with the help of the edge computing options, we can restrict the amount of data that comes into the cloud, but that's not possible all the time. And with different scenarios where we engage thousands of sensors, obviously the amount of data that we are going to receive at the cloud endpoints, they will be massive as well. And Kinesis is a managed service that can scale and that can automatically scale and take care of the varying loads. And once it receives, it can be passed to Apache Flink, where further optimization or cleansing can be done, right? And the processed data can be stored in Amazon S3. The difference between the Kinesis data streams and Amazon data fire hose is that the Kinesis data streams is more of a real time, right? But the data fire hose, it can store values maybe for every 5 minutes or every 1 minute. It can be configured. Every 1 minute, dump the data to S3, right? Or once we get at least 10 MB of data, right, make a write operation to S3. Right? That can be done. And with Kinesis data streams, it also can store the data for a very long period for more than 24 hours. So even if there are a billion data entries come inside your account, the Kinesis data streams, they have the power to store them, and they can also replay them multiple times. So let's say if I have 100 events captured here, I can pass the 100 events to one service and then pass the same 100 events to another service. Right? And maybe on need basis, I can replay the 100 events again or whenever I need. Right? So that's the power of Kinesis data streams. And Firehose, instead of Apache Flink, is for more intense or heavy operations. But if it is lightweight logic or transformation that we want to apply, we can go for AWS Lambda. Lambda has its own constraints. We cannot run Lambdas for more than 15 minutes, but they are scalable as well. Even if we get thousands, hundreds of thousands of records here, the Lambdas can scale. And yeah, we can achieve near real time operations with firehose. And this is additional operation. There are certain specific services available in AWS just for the transformation purpose. For example, this AWS Glue, they are well known for ETL. When we want to do the conversions, right? They can do the ETL jobs, extract, load, and transform. And they support maybe at least 10 to 15 types of sources here. S3 is by the one mentioned here, and the output could be sent to Athena, and Athena can further update and make some data modification, store it in another bucket for another region maybe. And that's the power of AWS Glue. It can talk to different database sources, and then it can write back to different database sources, including S3s. So different AWS services can be mixed and matched to meet the needs. So yeah, earlier we had a separate service just for IoT analytics, which was combining all these into a single pipeline, right? But now for some reason AWS decided to close it, right? So the recommendation is to use Dynasty data streams or Amazon data firehose. So for new customers, this service is not allowed, but if for existing customers, they can continue to use this service for some more time. So that's something we need to know. Right, we move on. So why machine learning? Right, we talked about collecting data. We talked about industrial IoT, where we will be getting large scale data. Right? And the problem with large scale data is we cannot write our own logic. So machine learning differs from normal way of solving problems by the way that machine learning uses learning rules. It's not like we write rules. The machine learns the rules. All we need is to train with the proper data set. And it becomes with large set of data, we cannot write the rules. First of all, defining the rules for different combination of data itself is very tedious. And even after defining the rules, we have to manually program it. And that is going to take a lot of labor hours and manual hours. And at the same time, machine learning is trained once we have the model generated, there is still one more level of training that is required with the latest data set right, before the model is deployed. I might get any number of lot of open source models available in the market, right? So we can get the model directly from Amazon Marketplace or other sources. But once we have the model, we have to train them with the data set we have, and then we deploy them. Once deployed, we get the following benefits. The machine learning helps in anomaly detection, predictive maintenance, real-time decision making, personalized recommendations, analytics and insights, automated control system. Personalized recommendations, you might have seen or heard different examples from Amazon. Once you log in, they will suggest some options for you. Right? The Amazon choice will be that label you can see, and then predictive maintenance is also more on the same line. Like the system by default, instead of reactively giving warnings, it will proactively take some steps, right, to prevent failures. Right. We'll see how machine learning works. There are different stages in machine learning, and, but it's not necessary that we have to go through and create our own machine learning model. As much as possible, for common use cases, there are machine learning models available. Even for all the water management problems, flood prediction, the models are already available. Okay? And all we need is a correct data set, so we can train it quickly and then deploy it and start seeing some benefits. But if you have to create your own machine learning model, then these are the steps you have to follow. First thing is, you have to clearly define the problem statement. What is the objective? What is that I'm going to solve with this new machine learning algorithm, machine learning model, right? And then you have, based on your problem definition, you have to focus on collecting the data. Once you have the data, do one round of preparation, right? And the data preparation is very, very crucial before training the model, before getting your model trained. And then pick the correct or appropriate algorithm. Lot of algorithms are available, right? Supervised learning, unsupervised learning, reinforced learning. Different algorithms are available. You carefully pick the algorithm that you think that can solve your problem, right? And once you have the data and algorithm in place, then you can go for model training. Right? Model training is compute intensive, and you might need distributed computing there. That's where cloud helps. There are a lot of managed services available where you need not even worry about how it happens internally. Right? But this is a crucial stage. Model training will happen, and once model is trained, you have to test the model. Right? That's where you give some test inputs and see what's the response back, what's the inference, and based on that you will determine whether the data you have fed to generate this model is an underfit or overfit, or it's an exact fit. Right? So if the results are so varying, either on the positive side, on the upper side or lower side, then it means you have to redo the data preparation, right? And then feed it back to the machine learning algorithm again, train the model again, do the testing again, and then if there are any fine tunings that you can do, like hyperparameters like that, you can make changes to the model, and then finally you can choose to deploy. And this is a cycle. After you deploy, it's not going to be over. Maybe sooner or later, maybe 6 months down the lane, 1 year down the lane, you will have more data in hand that can be trained so that your model can become even more effective. Right? At the same time, based on people's interaction, once your model is exposed via endpoints, let's say people will interact with the model, right? And based on their inputs, the model can even become a little more inefficient. Right? The the people's data can easily corrupt. Sometimes people intentionally do that also. So the model can easily go or drift from its original preparation, and we have to monitor that closely, and then do a retraining of the model is as as required. Yeah, open source models, there are a lot of options. You can either choose PyTorch, TensorFlow based frameworks, or time series models using ARIMA, long short term model, leakage detection. Also, we have several models available. Right? So these are the open source ML models which you can easily have access to. But there are pre-trained models that are readily available in AWS as well. Right? So instead of you picking a model, training with your own data, right, and spending time, you can readily consume the pre-trained models in AWS for your use cases. Right? For example, we'll see one by one. Amazon Recognition is one of the machine learning services that can help you detect objects. You can give input as an image. It can detect the objects that is part of the image. It can detect the scene, whether it's a landscape, whether it's a ocean or it's a natural scenery, right? Or it can detect activities, whether people are walking there or swimming is happening. It can detect activities just based on input as an image. Amazon Comprehend, it extracts insights from text. For example, you might have seen the reviews in Flipkart or Amazon or even now in Google chat space also. Google tries to comprehend or give a summary of what is happening. Right? Instead of you going over the new messages one by one, it summarizes the important part and shows at the top. And Amazon Transcribe, it converts speech to text. Similarly, we have Amazon Poly, which converts text to speech. Amazon Translate, it does a lot of language translations for the given text. And then Amazon Lex is used in chatbots and virtual assistants. I think it is also used in Alexa, maybe internally. The other trained models or machine learning services include forecast, where you give a time series and then it will give you the forecast. And this forecast is internally used in AWS itself. For example, you can see how much would be the billing or the budget for your usage, right? It can predict your usage pattern, or it can predict how much of bill you can expect by the end of this month based on the usage, right? Amazon Lookout, it can detect abnormal activities or anomalies in the metrics itself. For example, Amazon CloudWatch is what we use to collect metrics of different services, how the different services work together. And then Amazon Lookout, it can detect anomalies in these metrics. Amazon Personalized for recommendations. TextTrack is mainly used in medical healthcare industries where you have a prescription that you can just give us an input as a scanned document. It can extract the text from that. It can identify it's a doctor's prescription. It can identify the medicines, right? And it can give a summary that is easily understandable by the patient. Amazon Q Developer is similar to GitHub Copilot, where it helps generating code. So apart from this, ML, there are other ML services available in AWS as well. IoT Greengrass is kind of a edge runtime that you can deploy on your the on-prem. And there are few EC2 models available as well, Trainium and yeah, right? So if you want to train your custom models, then you can go for these type of EC2 instances, which has built-in ML chip, and because of that, because of the ML chip, it offers great performance and it can help you reduce the cost. You go for other high performance CPU, high CPU, instead of going for high CPU instances, you can actually prefer this ML based chips, ML based instances that can help reduce cost and give high performance as well. SageMaker, again on the ML services, if you want to do any custom ML models, SageMaker is the place to go. It takes care of the end-to-end workflow. You right from building the model. It has data wrangler which helps in cleaning the data, and it has CI/CD pipelines that take care of the ML operations. It can train the models, deploy. It can help validate. If you want to even debug your model at runtime, you can do that. SageMaker also has an IDE that developers can use to create your models. And then SageMaker Jumpstart, if you are used to Colab or Jupyter-based Python Jupyter notebooks, you can do similar operations here in SageMaker. You can easily import the same Jupyter notebooks here And once you have the data set, you can play around with the available ML algorithms or models. Okay, we are running out of time, and we'll quickly see I think I have 3 use cases and solution architecture for that. We'll pick 3 use cases related to water management problems and how it can be solved using AWS. One is water quality monitoring. For example, in the city, let's say we have a water reservoir that is used for drinking purpose, right? And the authorities now want to monitor the water quality of the reservoir in real time, right? And they have given a requirement saying that if the water quality deteriorates, right, I have to be informed, right? So how can we solve this problem? First thing is we have to choose the right sensors. In this case, let's go for pH sensor, right? Just one example, or you can include turbidity based sensor also. These sensors can include, if they can have the ability to embed IoT SDK, then it is well and good. Or you can have this IoT SDK installed on your computing device. For example, it could be your Raspberry Pi, Arduino, or Node MCU, right? And that can talk to IoT core, pass the pH values, in this case, this example. And the rule engine can positively filter out, it can possibly filter out, maybe if the pH value is more than 7, it can send it to Lambda. Right? And Lambda internally uses AWS SDKs to talk to other services. In this case, it can talk to simple notification service, which has the email, SMS, and other notification capabilities. So it can send an email alert to the authorities. Right? So this is how we can solve the water quality problem. We can implement a monitoring solution for water quality. Right? We take the next use case. Let's say we have a river, right, and we have a history of flooding. Right? Now the authorities, they want to monitor the river levels and predict flood events. Right? Instead of alerting or taking actions after the flood has come, we want to foresee this, create some alerts. We can use water level, we can pass flow rate sensors, and then pass the data to IoT core, and then here we deploy an ML machine learning model, which is already pre-trained with historical data for that particular location. That train the model and then deploy it here. Once it's deployed, the new data that we get from the IoT core, they get processed by this model, and the model can pass the input to AWS Lambda's JSON, and Lambda can again pass it to SNS, simple notification service, and it can send an email alert. Additionally, the Lambda can use or send the output to Poly. Poly is again another machine learning based service which converts text to voice. In this case, Poly can decode the text and make it as an MP3, and it can pass the MP3 through MQTT to another IoT device. In this case, the other IoT device, the end IoT device could be a smart speaker. Here, this is Amazon Echo. So through the IoT core and MQTT, the communication is bidirectional. Not that only the device can communicate to the cloud can communicate back to the IoT device as well. So in this case, the MP3 will be given as input to the speaker, and the speaker will immediately maybe create some voice alerts. Last use case, water consumption optimization. This is, for example, if you are in an apartment community and you want to monitor the household water usage and just to generate insight so that you can inform the the community people, so that during times of water crisis, they can at least be aware of how much water they use and how they can reduce the wastage. Right? So it's not possible to, even if it is not possible to attach these sensors for every individual apartment homes, at least at the block level, we can introduce these water flow sensors, collect the data, and if the data is more, if the frequency of data that we collect is more, they can be fed into Kinesis data streams, and they can be stored in DynamoDB. And once the data is stored, we can use pandas to retrieve the data from DynamoDB, apply some additional logic there, and then finally fit into QuickSight. QuickSight is where we can see all the charts and get some insights. What is the usage on every Monday morning? What is the usage on every Monday evening? And residents, it can be presented to the residents, and later they can use their best judgment to see what they can do to reduce the wastage. Right. I have given few links which could help you get started. One is how you can get your device data to dashboard in 10 minutes. Right. This uses IoT Core and Grafana, and then the other one is the IoT channel for on YouTube. The last three are Udemy courses, which I am currently using to learn about the AI and machine learning. So I think when you get an offer in Udemy, it could be as low as 499 rupees, and it's definitely worth your time. So if you are really interested into machine learning or AWS and IoT, these three are the first go-to resources I would recommend. I so thank you. Yeah, questions? Maybe I don't know.
Participants, any queries? Participants, if you have any queries, please you can ask. Is there anyone with queries?
Okay, if you don't have any questions, no problems. The objective is to get you exposed into some of the AWS services. So even if you have not tried AWS in the past, just give it a try, right? And if you, I'm sure you will definitely find it useful, and at least how you will, when you come to know how AWS has solved a lot of these problems, you will also think in the same way, right? It's not like you have a solution in hand, you want to find a problem. When you find a problem, you try to find the optimal solution, and that will be really helpful for everyone. I shared this presentation with the coordinator. Maybe I think from him you can get it.
Any queries means you can ask him. Please respond. Do you have any queries? Thank you, sir. Thank you for a wonderful session, sir. Thank you.
Thank you, sir. Thank you. Thanks for your time. Stopping off.
Participants, the feedback form will be shared shortly. The next resource person will join us by 7:40. Okay. Please be online. So he will be joining by 7:40.
Your voice not audible.
Yes, sir. The resource person will join by 7:40. So please, that feedback form is being shared. You please fill that. He will be joining us by 7:40.
Hello everyone, good evening.
Good evening, everyone. We are pleased to have Mr. Sriram as our esteemed resource person for this session. With a wealth of over 18 years of professional experience, Mr. Sriram currently serves as an SEM Solution Manager in Dubai. Mr. Sriram's journey of expertise is enriched by his prior roles at globally recognized organizations. His professional timeline includes significant tenures as a senior principal consultant and principal consultant, wherein he demonstrated a deep understanding of business operations and technology solutions. Before his current position, he excelled as an Oracle functional consultant with 4i App Solutions, a leading provider of cloud solutions. Please join me in welcoming Mr. R. Sriram. Welcome you, sir.
Thank you, Morgan. Thank you. Sorry, I was a little late, and you have to apologize for that. My health condition, I am not well. Probably my voice is not that feeble, maybe muffled. And quick background about me: I have been around, in this industry for last 17 to 18 years. I had 2 years to finish 2 decades in the industry. I have completed my UG and also the masters in electrical electronics, and I have versatile experience uh, in manufacturing, maintenance, robotics, special purpose missions, and designing. And then slowly I moved to consulting. So application consulting in the various verticals of supply chain, uh, then service, and then maintenance. There are a lot of experience I have. And currently I'm located in outside India. Uh, this is what my overall experience. I am a part of apps consulting now. So let me take you through that, you know, the smart water distribution network, which we are going to discuss for next 45 minutes to 1 hour. You can feel free to stop whenever you require. Hope you can see my screen.
Shared.
Can you share my can you see my screen? I have already shared the
Yes, sir.
screen.
It's shared, sir. It is visible, sir.
Okay. Okay. So what is water distribution network? So the water distribution networks are, it is one of the key essential for our day-to-day activities. So without water, we cannot survive, right? So how that distribution network is working, and what are the key elements in the water distribution network? So take an example. What are the key elements? So these key elements are pipelines, pumps, walls, storage tanks, sensors, walls, etc., etc. There are a lot of things which is a key element for you to bring the water from the reservoir, wherever it is a reservoir, to your consumption area, to the consumer area. So that is what the water network it all talks about, right? And why it is important. So the importance of the water distribution is always like, we need to have a clean and safe drinking water. That is for both the urban and the rural population. See, water is essential for agriculture, industrial process, or day-to-day activities, including the health hygiene and the sanitation. So, as we all know, how important that water. So, without the water, can we survive in a day? It is impossible. We cannot. So, can we survive without, proper drinking water or without any, quality of water? No, we cannot do that. So, it's all about that how the water is getting distributed and what quality of water is getting distributed and how are we going to use that water. So today we are going to discuss about that, how the water is getting distributed with the latest technologies, with IoT devices, AI, and etc etc, with all the electronic devices. So you would have been heard multiple times about IoT and AI in the market. So that is spread across not only with the IT, not only with the networking, not only with the computers, not only with telecommunication. That has been spread across the utilities as well. When I say utilities, that is for electricity, water, and etc. etc. Even for transmission of power and transmission of water, and also have all this latest technologies to monitor the transfer of water or utilities from one place to another place, with a lot of latest technologies are available in the market. Okay, so what are the smart water networks? So this is a pictorial representation how the integration of digital tools into the traditional water distribution system. Features like the real-time monitoring and automated control. What is mean by real-time monitoring? So the real-time monitoring, like somebody sits in the data center, or somebody sits in the monitoring monitoring place, where they want to monitor how the water is getting distributed from one place to another place. Do I have any leakage in that? How efficiently, effectively that has been transformed from one place to another place. So there are a lot of technologies are put in place, like a leak management. You can see from the pictorial representation, from one place to another place, where it is getting the data is getting transmitted through help of a sensor, IoT, and many other devices to the respective data collection center. Okay. Again, one more pictorial representation. This is what the water source. So for the left side, you can see the water source, how it is coming from the pump side. Let me take the pointer. Okay. So this is what the water source, and from the pump, it goes to the chlorinization, and then it goes to the filter bed. From there, it goes to that clean water sump. With that, there are devices like a turbidity meter, pH analyzer, conductivity analyzer, level meter, chlorine analyzer, local display, everything. It goes to the IoT. Couple of minutes back when I spoke about IoT, so you can see that how that IoT information is getting transformed to the cloud. From the cloud, you can see it is going to the gateway. There are a lot of gateways. Individual operators, they have a different gateways. So that gateway capture that information, and it can be a report, it can be a data analysis, it can be anything. They can monitor each and every performance, or each and every that activity of individual transformation from one place to the another place. So including the pressure sensor, flow meter, and here on one more flow meter, everything is goes to that one. So it has a various stages. So the left side is we can call it as a stage one, and right side is a stage two, where it goes to the distribution area. From all the stages, that information is getting collected in the cloud, and it goes to the water management control room. So the control room, in one place, I can sit and I can monitor what is happening. I need not to run pillar to post to identify what is happening on the ground, what is happening in the reality, to find out where is the leak, or where is the what is the pressure, if there is any pressure deepage in the particular area, or is it the flow meter is a overflow or inflow. So all those things I can identify from the water control room. So this is the advantage of having all the technologies in the distribution system to help you to grow further, and also it make us less sophisticated. Okay, what is the market size? The market size is, again, this is a statistics on 2023. It comes around $16.6 billion, the market size, and the predicted growth is annual of 11.3% between 2023 to 2032, with a value of $42.2 billion. That is a expected market size by 2023. 2032. One more chart. It's how the trend analysis shows about here. The smart water management market size started from 16.6 on 2023, and the expected growth rate on 2032 43.51. So how does it work? So it always need a human input. Without an human input, or without a supervision, or the creativity of a human nature, all those things it has to put in place. Like you can see that organization, creation, delivery, and supervision of water always resource using the different IoT technologies. So these technologies aim to enhance the transparency and promote a mindful and sustainable utilization of water resources. So the main um, the technology, how it will enhance you, that is what we always focus on that. So that enhance the transparency and promote a mindful and sustainable utilization of water resource. That is the key important outcome from this kind of technology utilization in the in this kind of transformation, in this kind of utility transformation. So this idea covers a range of areas such as agriculture, farming, industry, services, and urban areas. So it also, span across multiple household water consumption, water level, purity of water, chemical leakage, and also the pressure shift in the pipeline and water quality in the aquarium. Okay, so this is how it works, and this is the key important for that. Microcontrollers and sensors like ultrasonic flow, temperature, salinity, conductivity, humidity, pressure, and sensors are installed on pipes or pumps to monitor water levels, flow rates, temperature, and water quality in the real time. Right. So as I said some time back, so it always with comes with the latest technologies and microcontrollers and sensors that will help to identify everything in that. So for example, for the temperature or the pressure identifier, it will monitor and give you the data to the control room. With that, you can identify everything. So information and signals are captured by the sensors, are transmitted via IoT internet to a cloud server where they undergo processing analysis, frequently supported by the AI technology. So with the latest technology, we always talk about AI everywhere. So the AI, with the help of IoT, it will capture all the information from the transformation where the data is getting collected to IoT and the data is getting transferred to the data center. From the data center, it goes to the control room. From the control room, you can monitor everything. So always that AI and IoT plays a vital role in this kind of a monitoring system. Okay, the process information is then transmitted to the user terminal for review and consultation. The review is capable of managing the review is capable of managing and overseeing the utilization and quality of water resource while also adding and upkeeping the necessary equipment. Okay. So types of IoT powered water management. So smart water metering system and smart dam monitoring system. So what is smart water metering system or solutioning? So smart water meters help in real-time measurement of water usage and transform this data from consumer to the providers. This solution not only streamlined water management but also enhanced the precision of billing processes. So how that meter readings are getting generated today? So the meter readings are the real-time measurement of water. So based on that only the billings are you have to pay the bill or any industry where they are consuming the waters in gallons. Those all those things nobody go and monitor what is happening. With the help of an IoT, everything will be captured automatically. That information will go to that billing system. From the billing system, the consumer has to pay that invoice, right? So it will always helpful in the water metering solutioning. And the dam monitoring. What is dam monitoring? This system monitors the water level across all part of the dam. If any unusual changes are detected, an alert will be sent to that authorized automatically. So if it is any unusual things like a water level, automatically the system or an IoT drop a message to the through the transmitter to the data center. From the data center, that information getting captured and it can alert the supervisor or authorities to take a necessary action. To be continued with that, what are the IoT powered water management? Other things are like a river water quality monitoring, smart water resource control system or solution. So these are the tools. What is river water quality monitoring are the tools to monitor the quality of water, especially in the river that act as a source of a drinking water. Smart sensors typically gauge parameters like water temperature, turbidity, and the sustainability for the drinking, it all will be monitored by using an IoT in the river water quality monitoring. Right? And the smart water resource control solution city, like an administrator, must oversee the management of water supply, equipment, and usage. Innovations like IoT offer the potential to enhance the visibility and transparency of the water supply process. So IoT sensors enable access to real-time data and advanced analytics, providing a robust basis for making crucial decisions. So what are the types of IoT powered water management? So smart water leakage detector. So what frequently we practically and frequently we would be facing a lot of things on the water leakage. Since that the transformation pipe may transform across city to city in a various geographical locations, right? Or within a city also from various areas. So it is always bound to happen some kind of physical damage to that pipe, and so could be a reason to have a leakage also in the pipeline. So how it is getting detected with the help of an IoT, that also can be detected with fitting the problems, and pipeline can persist for an existent period. This leads to an additional damage to pipes and the disruption in water supply. So IoT sensors plays an important role in the timely detection of such issues, preventing the potential damage for more severe consequences. So if we proactive measurement will always help than the reactive measurement. So that's what the detector will help you to take a proactive measurement. Okay, what is the need for the IoT solution? 70% of our planet is trapped in water. If you find the statistic comforting and questioning the need to prioritize such an abundant resource, it is a time to reconsider. So water scarcity is becoming an increasing concern. According to the reports, around 20% of the world population will experience this effect by 2025. By 2040, approximately one of every four children worldwide will reside in the region facing severe water shortage. So this challenge is not confined to developing nations alone. Fresh water, essential for drinking, hygiene, agriculture, and cooking, is incredibly scarce. Merely 3% of the earth water is fresh water, and the significant portion of that is about two-thirds is either locked in icy glaciers or inaccessible for our use. Design of smart water network. One of the primary smart utilities that is concerned in any smart city is water distribution network. If the traditional city-wide water distribution network is made smart with the help of IoT technology, it becomes effortless to identify water consumption patterns, water quality, and detect water leakage in real time, leading to water conservation in any given day. Okay, so important consideration: understanding the demand requirement of a city in a dynamic fashion, considering the continuous expansion of the city. So we need to keep consideration all those things when we are, when we are implementing about or the scaling about that IoT and other technologies in this kind of water management system is primarily, the city expansion. So that is one of the key consideration. And supplying consumer with the adequate amount of water so as to meet their consumption need. Yes, of course, there should be adequate amount of water should be there. And detecting abnormal condition in the water network, such as leakage, break in pipes, failure of wall meters, and addressing them on a priority scheduling basis. So monitoring the quality of water delivers to the customer and facilitating treatment cycles in the event of water contamination. So you have to monitor like the quality of water getting delivered to the consumers are the key critical stuff. So it always to be treated well to avoid that water contamination. So these are the most important consideration. So the real-time example. So so far what we have been discussed or explained about the smart water management. So the next question may arise: is it all only on the theory? Something has been practically implemented? The answer is yes, it has been implemented. The smart solution for a city-wide water network, with the city survey help of KU IDFC Government of Karnataka, has been performed by analyzing the traditional water distribution network in a smaller city of about 4 kilometer radius in India. So this is already taken as an example or a role model or a pilot project by government of Karnataka for 4 kilometer radius. They have implemented and they are getting a quality results as an outcome of this particular initiatives what they have taken. So the government of Karnataka also, what I read from the document, like they are planning to expand this furthermore to various geographies within Karnataka and also more than 4 kilometers radius to get the more benefit out of it. So the beginning point of water distribution to a city was a water reservoir which was located about 50 kilometers away from the city. The water from the reservoir was sent to the water treatment plant before it was distributed to the city. So the water treatment plant was about 5 kilometers away from the city. Some of the primary water quality parameters such as pH, turbidity, and the free residual chlorine were tested and treated. Drinking water was pumped to two different ground level storage points, which were located at the different altitude. Okay. So based on the site survey, it was understood that with the help of sensors or actuators and IoT-based technological solution would help the water distribution authority to account for the water from the source of destination to find out if there is any unauthorized tapping of water. Easily, water balance sheet or a tally sheet could be generated with the help of the IoT-based wireless technological assistance. So when we speak about unauthorized tapping of water, so how do I monitor if there is any unauthorized tapping of water? It always based on the water balance sheet or a tally sheet. So I need to find out what is my inflow and outflow. So that can be monitored through through an IoT device. With that IoT device and the sensors, that will help the team to identify what is the tally, or how it is getting tallied, or what is my inflow and outflow. So those kind of things can be monitored with the help of an IoT and also the sensors and other electronic devices. Inclusion of various sensors or actuators to the wireless solution to find out water flow rate, pressure level, and water quality along with the motorized value to control the water flow in the distributed channel would enable the complete online automation process from sensing to data storage and the analytics. So this is another pictorial representation of schematic view of typical water distribution network, and it is self-explanatory. From the reservoir, it goes to the water treatment plant. From there, it is going to the ground level storage, and then through the pump and the pressure sensors and leak detectors, it goes to the elevated storage tank, and can be many. From there, it goes to area 1 and up to area N, and all the informations are getting captured in the analytics and the control room. Okay. So again, the explanation of that schematic view, the typical city-wide water distribution network from the reservoir to the end consumer with all the possible sensors and the actuators. And number 1, as highlighted in the figure, is a reservoir. Number 2 is the water treatment plant. Number 3 is representative of 2 ground storage point with 1 elevated altitude level. And the 4th is the storage point. 5th is a zone, and 6th is the consumer node with the flow-based sensor. So again, there's an explanation or a snapshot of that pictorial representation. And the water distribution channel consists of motorized control valves that help in completely or partially closing the pipelines. Yes, that is one more important point, is how do you close it? The pipeline, not necessary that we have to close all the pipeline if there is any leakage has been identified with the help of an IoT. So they have some control valves and the local valves, pilot valves. There are a lot of valves are there. They may close that valves and take a necessary action to arrest a leak or or change the pipe. It could be any reason, right? To take a proper maintenance activity. So the distribution channel also consists of pressure sensors to identify any water leaks. As I said, the water leak is one of the most critical, very frequently happening in the ground, because that pipes, many places it are under the ground, many places are above the ground also. It is an open in the open area. There are a lot of chances to have a physical damage. The data collected from each and every sensor or a node, which would be received by a gateway and sent it to the server for possible analytics. Okay. So this is the data flow architecture. How the data flow architecture work here, you can see this is an area 1 and area 2. So from here, though, you can see that consumer node 1 up to consumer node 4 and receive the data, transmit the data from here to the gateway. Again, actuator node also will send the data to the gateway. Area 2, also the same. Area 2 can send the consumer data and actuator data, no data to through the gateway. So CDPAC and wings through the gateway that can go to the database. So the database is nothing but application server can have a database and multiple ways of doing it on. So it can be in a cloud, it can be in a, on-prem, lot of ways to capture the data, store the data, massage the data and populate the data and present in a report or analytics view as per the customer demand or as per the business demand. So there are various gateways out there. There are public gateways are there. There are accelerators are there, and a lot of public APIs are there. There are a lot of things are there to transfer the data from here to there, and from there it will go to the data cloud or on-prem. From there it can be generated as a data analytics. Okay. So what is system architecture with the focus on designing and developing smart water meters and billing system for domestic consumers, remotely operated automatic distribution values and system for water quality monitoring is designed. An IoT driven architecture was developed and experiments were performed by applying analytics on the data collected from the network. The scope of the system is limited to the water distribution network from groundwater level storage point to the end user and exclude the original water source and the water treatment plant. The test bed consists of two zones, Area 1 and Area 2. Area 1 is supplied with water from the elevated storage point, and Area 2 is supplied through elevated storage to which water is pumped from the ground level storage point. Unlike Area 2, the water to Area 1 is distributed through the gravity since it is located to a certain altitude. So the figure 2 shows that system level architecture of the water test bed. So area 1 and area 2, we have seen that area 2, unlike area 2, the area 1 is distributed to the gravity. So area 2 need a extra uh, uh, um, pumps and all, since it is an elevated area where there is no gravity. In that places we may need an extra support. So area 1 consists of motorized control valve that modulates the flow of water from the source of four consumer points, one pressure sensors at the elevated terrain storage point helps in finding out the water level in the tank, and other pressure sensor is deployed in the distribution line. The quality parameters of water such as pH, turbidity, residual chlorine are monitored before the water is distributed to the consumer nodes in the area 1. Area 2 consists of groundwater storage tank, and the water is pumped from the three elevated storage point and further distributed to the five consumer nodes. The water flow in the distribution channel to each of the elevated storage point is modulated with the help of the motorist value. All the sensors and actuators are connected with IEEE 802.115.4, the wireless trans receivers that are designed in-house. Then in-house designed gateway aggregates the data received from area 1 and area 2 and sends the data packets to the server for analytics. So this is the some in-house wireless trans receivers, and this is the some standard or some naming convention they have kept it for that wireless receivers, and those are in-house design. The consumer node consists of a Hall effect based flow meter and the latching type solenoid control. The consumer node is connected to a IEEE 802.15.4 compliant CDGA UP mode. Again, that is a type of looks like a type of a gateway that what they have developed in the gateway and what they have developed in the data architecture that looks like that one. So the latching type solenoid helps in micromanaging the water flow at every consumer node remotely from the dashboard. And there are options to supply power to the consumer node externally as well as through the battery. Okay, so the functional block diagram. So the functional block diagram is flow meter, solenoid, power supply, and UB mode. Like consumer node, all other sensors and actuators mentioned in area 1 and area 2 are connected to the IEEE 802.15.4 compliant CDAC's UB mode R. The CDAC's WINS is a custom design board with multi-network interfaces, which is again, it's a custom designed interface application process at Linux kernel level. So it is at the purely at the DB side. Wings gateway is a built with an onboard transceiver for IEEE 802.15.4 through which the gateway communicates with the wireless sensor nodes. The gateway collects and transmits the data to IEEE 802.15.4 network and also communicate to the server. The custom application stock is implemented on the transceiver chip of the board to transfer the data between the IEEE 802.15.4 and the node.js server. Node.js server handles the data transfer between the message queuing, telemetry, transport, that is the MQTT server, and IEEE 802.15.4 transceiver. Also, Node.js converts the data from JavaScript object notation, that is JSON, to IEEE 802.15.4 packet structure on the VICE. The MQTT is a lightweight and publish subscript-based messaging protocol. This is used in communication between the server and the gateway. The server contains a MQTT broker, web app, dashboard, and the database. The MQTT broker communicates to the gateway to publish data to the topic titled water, PINID, command, and to subscribe the data from topic water, PINID, and the data. The web app validates the data coming from MQTT topics, waters or PAN-ID or data and water PAN-ID or command. Along with web app, also validate the data transmitted between the user and the server with the help of the dashboard. After validating the data from various sources like MQTT broker, dashboard, the web app updates the information into the database. So this is the data flow model, how that will work. So in the top, we have three boxes: sensor, gateway, and server. And the flow from initiating the request to the gateway and authorization, sensor data all goes to the gateway. From the information, it goes to the server with the water pan data or water pan ID data or water pan ID command. So that information, it goes to the server. And again, based on the user input or query, it will come back to the database, which is DB is a database. The data could be stored in the database. So that sensor information passed in through the gateway. From gateway, it goes to the server, and the server, the information gets stored in the database. So with the help of the database, that user can query or can put a further input on the database and can get whatever the data want, as long as the data is available in the database and the data can be retrieved as per the as per the need of the consumer or as per the need of the command center. So the wireless sensor nodes collect data from the sensors and send it to the gateway over IEEE 802.15.4 using custom application protocol. The gateway extracts the data received via IEEE 802.15.4 and converts into a JSON string format as shown in table and publish it to topic, water, PAN ID or data via MQTT. So the MQTT broker on the server receives data upon subscribing to the water topic, PAN ID, and data, and the server stores the received data into the database using a TCP or IP. The server also updates or notify the dashboard with real-time data, which I explained on the flow diagram. The same thing here they have explained that the sensor and data information goes to the gateway. From gateway, it goes to the server. From server, it goes to the dashboard. Server is nothing. From the server, it goes to database. From database, they can retrieve the data in the form of a dashboard. Dashboard is kind of a dashboard or a real-time report or an analytical report. There are a lot of ways to populate the data. The modern best practices are there. So the communication between the server and the dashboard is via the REST APIs. The dashboard sends the control or command signals to server with the user intervention. Based on the type of command, the server receives the state in the database is updated and the data is published to the MQTT topic. The MQTT client on the gateway subscribes the data from the server and converts into the IEEE 802.154.4 packet structure and send the data to the respective wireless sensor node. So that data can be communicated through REST API. There are a lot of APIs are available, and there are something or public APIs are available. Anybody can, as long as to communicate with the two databases, that APIs are available in the publish. Some customers and some vendors are publishing that API for the public to utilize that API. Some are like a subscription-based APIs that you need to pay for that API and you have to get that API, REST APIs to use that APIs. There are a lot of ways are available in the market. So the dashboard serving both Area 1 Area 2 is designed and developed. The corporation, municipal authority, or site engineer would be able to configure all the nodes to the dashboard. The site engineer also has a privilege to control the water flow in the network. The details of the complete analytics of the entire water network automation are not included in the article. However, the consumer level, water level meter billing, and monitoring of various quality and quantity parameters are designed. So this is how the dashboard looks like. So from here, you know that from the tank, it goes to that, the butterfly tank, a lot of flows, outlet flow data 2, outlet flow data 3 and 4. And these are the valves. And the water flows from here, the dim line, and goes to this. You can see the arrow mark in the picture. From here, it goes to this, and there is a pressure wall, and the pressure wall, it will goes to that. So all this information as available in the dashboard, as long as the data is available in the database. Okay, the figure shows the water meter billing for consumer 2 in the area where here it is assumed that a liter of water cost about 0.03 rupee. Hence, for consuming for 156 liters of water from Jan 19 to 28 of 2018, the consumer is charged with 4 rupees 68 paise. And the time period could also be selected for any duration for the particular month, and the amount of water consumed and the bill amount of the particular consumption could be viewed on the dashboard. So it is a self-explanatory, like it is like nowadays you can have your own customer portal login, and most of the electricity and some of the water distribution center like this, where you can find how much you consumed and what is the node name and what is your billable amount, everything from the website or a customer portal. They call it as a customer portal. So from the customer portal you can get this information. So again, trend analysis. So the meter billing for consumer 2 in area 1 from 19 to 28th of Jan, and water pressure in the distribution line, that is from 15th and 29th of Jan, and the water quality parameter. Again, this was for trend analysis. Water turbidity. Again, this is one more trend analysis starting from 19th to 31st of Jan with turbidity NTU value and the pH value. Again, one more representation from 19th to 31st of Jan with a pH value, the maximum of 8. Okay. So area-wise node level representation. So the green on active nodes and the orange ones are inactive nodes. So area 2 are inactive and area 1 are active. And the pressure and all the dashboard information shows about that about the consumer area. So scalability, yeah, it can be scalable when it comes to hardware and the network scalability. Since the CAD's UB mode is IEEE 802.115.4 compliant and Wings is a multi-protocol gateway, the network is easily scalable and not just limited to the wireless personal area network. In case of software scalability, the server that handle multiple requests from end node through the gateway is flexible to accept any type of sensor or actuator and also creates entry into database from which the dashboard can be configured. Yes, of course, any latest technology and where it will be scalable with the help of an IoT sensors and software and hardware. Of course, it can be expandable. There is a scalability for there is a scalability for new technologies always available. So far we have been discussed about uh, you know uh, in an optimistic way and what are the advantages of having the system. If you ask me, is it that smooth without any challenge? Yes, of course there are challenges. So the challenges are installation cost is pretty much high when compared with the older traditional method. The cost always plays a role, right? So that installation cost is little high in certain areas, especially in the developing nation dealing with the issue of significant struggle, extremely high of infrastructure development and limited network reach when the gadgets are set up in an area with weak signals like a basement, the system might struggle to ensure immediate data exchange. Of course, the network is another issue and problems with the interoperability. This is a new challenge in connected, to one before it. Various companies might create IoT devices of a single smart water system, which could lead to difficulties in making them interact smoothly with another. Lack of standardization, the absence of universally recognized standards among the IoT system developers in water management cause challenge in aligning the integrity tools provided by the vendors. So the standardization wherever we go, any kind of an industry, it is not limited to the utilities. It is not limited to the latest technology. It is not limited to uh, uh, water system. It is applicable everywhere. The lack of standardization. The standardization plays a role as a part of process. Because of that standardization, there are a lot of challenges will come into the ground reality in the implementation. So the standardization is a key vital role when there is a plan to implement this kind of an advanced technology. Then uh, uh, it will always be a challenge one. When there is no standardization, there is a challenge in the implementation. So the conclusion: a site survey has been conducted to understand the traditional water distribution network and also understand the inclusion of IoT-driven technology to practically connect and record every water parameter in the server for post or real-time processing and analytics. An IoT-driven system architecture design and the water test bed that represent a typical citywide water network is deployed. So this is a key and most important as real-time processing and the real-time analytics. So as a conclusion, if we go with the IoT-driven technology, the practically the various parameter can be collected and pass on to the server, and that information can be generated as a real-time processing and the analytics. That will help in a lot of ways to take a proactive measure rather being a reactive measure. So CADS IEEE 802.15.4 compliant UB mode and multi-protocol gateway wings are used in collecting various water quality and quantity parameters, and with the help of MQTT protocol, the data packets are sent to the server through the gateway in the form of JSON. The dashboard is architected for the usage of a site engineer in the water distribution board. The water was circulated in the network and the parameters are recorded and plotted in the form of graphs and other representation. The designed smart water testbed solution is scalable to the citywide network in terms of hardware, network, and software. Yes, any new technology can be scalable. Any new design that can be scalable in terms of hardware, network, and software. So these are the some reference document which has been, you know, which has been referred to collect such information, and you can go through this one. And this is publicly, this informations are very much available. So that's it from my side. Thanks for listening for the last, I believe, 45 minutes to 1 hour. This is all about the water management system with the latest technology.
Thank you, Sriram, for delivering such an inspiring session despite being hungry. Any queries from participants? Participants, kindly respond. If you have any queries, you can ask.
Okay, thank you, Mr. Murugan. Thanks for giving this opportunity.
Thank you.
Thank you thank you so much for giving this opportunity, and thanks for all the participants in the late evening on Friday evening and sitting for this session for almost 45 minutes to 1 hour on late evening, late Friday evening. I know how difficult it is. In spite of that, it was quite interactive session, and thank you so much for your participation. And Mr. Murugan, thank you so much for arranging this one and giving me an opportunity to explain about some informative information for a spread of around 70 plus people in the late evening. Thank you so much for inviting me.
Thank you, Sriram. Participants, the feedback link will be shared shortly. So tomorrow's session will start at 2 p.m. Okay, it is not 6 p.m. Tomorrow's session will be starting by, you will be having three sessions. Okay, so the first session will start by 2 p.m. Okay, so be online. So tomorrow your assessment test will be conducted as well as all your feedback or to be needed to be collected. Okay, so please be in a formal dress so that we have to take a photograph tomorrow. Okay, we need to take some photographs. We have to switch on the camera and we need to take the photographs, and then we have to produce to ATAL FDP portal. Okay, so please be on a formal dress so that it will be possible for you to open the camera and show on the faces on the camera. Okay. Thank you. The feedback link will be shared shortly. Thank you.